Good morning everybody. Today I am going to discuss numerical problem that often asks in an exam, okay, based on partition function and as well as application of partition function and free energy in a real life problem. So why this chapter number 3 Pathria book is very lengthy, okay, and this chapter why I am going slow, because this chapter is very much important for exam purpose. Number one. Number two, if you understand density of function, partition function, free energy, passive heat, then entropy, then you can understand most of the part related to the physics. Okay, for example, suppose if you know the entropy relation, partition function, you can calculate the passive heat of solid by Einstein theory. Okay. Einstein. Similarly, if you understand the application of partition function in paramagnetism, okay, then you can easily understand condensed matter physics. Number one. Number three, if you understand, suppose harmonic oscillator. So harmonic oscillator is everywhere. Okay, it is related to classical mechanics, it is related to spectroscopy, vibrational phenomena, it is related to particle physics, it is related to electrodynamics. So if you understand the vibrational phenomena or harmonic oscillator, then we can understand rest of the chapter easily. So that's why I am going very slowly, and I am also discussing some specific numerical problem, that type of often action in an exam. Okay. Today actually I am going to discuss one or two problems. After that I will move to the application of partition function in a real world problem. For example, harmonic oscillator. Okay, first of all I will discuss two problems related to partition function. This type of problem often asked in an exam. Okay, question number one. Okay, question number one, just wait. Question number one. You listen the question carefully. If the partition function or d-dimensional crystal, if the partition function of d-dimensional crystal is given as z equal to 1 by factorial n. Okay. Vd is to the power d twice pi m k t to the power d by 2 to the power n. Okay, this is the partition function of a system of d-dimensional crystal where n particles are indistinguishable particles. Why? Because there is a n factorial. Okay, this is d means dimension. Okay, n is a number of particles, so n numbers of particles. Therefore, total partition function is to the power n. Okay, now so that free energy of the system and where alpha twice pi m equal to alpha and E equal to nkt. Okay, so that free energy you have to show that free energy equal to ktn 2 ln n minus ln x minus 1, where x equal to v d alpha d by 2 E d by 2 and h d by 2. This is the problem. Again I am telling the problem. The partition function of a d-dimensional crystal where n indistinguishable particle is there is given by this one. So that free energy of the system is kt ln twice ln x minus 1. Can you show? So it is very easy. This I am removing this part. Okay, I am removing this part. How can you do? Solution is very simple. F equal to kt ln z. Okay, this is the formula, and this formula is given minus kt. This first term will be minus ln n factorial. Okay, why minus? Because 1 by n is reverse minus ln. Second term, this is alpha, is already constant, every time is constant, so I can put it like this. n is to the power n to the power n is there. So if we take a ln, then n will come out ln vd alpha d by alpha e d by 2 h d by d, okay, 1 by n. From where I want take 1 by n, because they have given e equal to n kt. Okay, then I replace e kt by 1 by n, and now you take the logarithm. It is very simple. First it is n factorial. First term will I am removing this part. I am simplifying one or two steps. I am not going to detail, and this is the simple calculation. kt, this will be minus n, minus will be plus, minus is I have removed here, ln n factorial plus n. It is a Starling approximation. Starling approximation, you know the Starling approximation. Starling approximation, ln n factorial equal to n ln n minus n. Okay, I put this value here because minus plus, and this will be minus n ln this. This is suppose is constant. You can put alpha, okay, divided by n. Now you can do the simple calculation. If you take this one, and finally you will get the result. Okay, this way you have to solve. It is only 5-mark question in NET exam. Second question is very carefully read. Second question, you carefully read the question. A system of ideal end gas where n distinguishable gas particle is there in two-dimensional box. That means in a two-dimensional box there is a n distinguishable ideal particle, gas particle. Okay, distinguishable. This is having dimension, having area is equal to L square. Suppose this is a two-dimensional box, area equal to L square. There's a n numbers of particle, gas particle. Okay, so that partition function equal to, so that partition function equal to 1 by n factorial a square twice n e by n to the power n. You have to show the partition function in this one. Okay, provided n one term is given, that is E equal to, this is n kt. This is the mean energy. Mean energy of the system is given E equal to n kt. I am again telling you n numbers of this indistinguishable particle in two-dimensional box having dimension area equal to L square. Okay, and average energy equal to n kt. And what is the total partition function of the system? So, and forgetting, and one condition is given, forgetting about the additive constant. Forgetting about the additive constant means constant parameter you have to avoid. Okay, so I am giving you you can if you remember the general formula I have given you, that you can remember the general formula. Partition function for general formula. Okay, general formula. If you can remember, this is the general formula. Vd Hd twice pi m kt. Okay, to the power n. And here one condition is a additive constant, pi is taken as a 1. This condition is given. Okay, now this is the general formula, d by 2. Okay, now it is two-dimensional box, so d equal to 2, 1 by n factorial, v square means area, a square twice m kt, 2 by 2 it is 1 to the power n. Is it okay? And now E equal to n kt they have given, so kt equal to E by n. Kt equal to E by n, you can replace 1 by n factorial. V square means area. Okay, area, a square twice m E by n. Is it okay? To the power n. Now you remember, this is the partition function of the whole system. Whole system means system consisting of n particles. Suppose if I ask you what is the partition function of individual particle, then factorial n will not be there, and power n naught will not be there. That is partition function is this one. Okay. This is you can do only when you remember the general formula of partition function. But if you suppose you don't know the general formula of partition function, okay, if you don't know the general rule of partition, then how can you remember what is the formula of partition function? How can you remember? You can do like this: e to the power minus beta is okay. Is it okay? E to the power beta is into d omega 1 by hd. Is it okay? This is the general formula in terms of phase space volume. Okay, but suppose if you can, if you want to remember general formula, you can replace e to the power minus beta h. Beta h means you can replace e. Okay? H means Hamiltonian represent the total energy. You can simply represent the z d. Okay, this is z d dimension. Okay, now question is 2 dimension. Then the density of state you have to replace the density of state of 2-dimensional density of state you have to replace. Okay, why I am not writing 1 by h cube? Because h cube is already inside the density of function. That's why I am not writing when I replace here. Okay, but in case of this you have to replace. Now, what is the dimension? Now suppose if I want to use this formula, then how can I represent the density of state? It is very easy. How can you represent the density of state? You can use this formula, you can use this formula, that is up to you. Okay, which one is easy? Suppose here it is, if you want to use this formula, then you have to use a square. This is 2 dimension. Then e to the power e square. Then you have to write this px by twice m plus py square by twice m plus v. We are not going to calculate because there is no, in the question itself it is clearly written there is no interaction, means potential energy is 0. Then you have to write beta is there. Then you have to write d square, means one is dpx dx, dpy dy. So this is a 2 integration. This integration will give what? This integration, first time integration will give this. See here p only px, there is no x and y, so this time dx dy it will give x and y. So x and y means xy. This is area a square integration px square by twice m beta dpx e to the power minus py square by twice m beta dpy. Now this is a gamma function integration. You can do, this is the area a square. Okay, if you do the gamma function calculation, you will get twice m kt to the this one. This is very easy. So this will give a gamma function. Okay. But if you don't know the gamma function, I am going to give you after that. I have already given you solution how to solve a gamma function solution using gamma function. Okay. This is how you can do. So how do you integrate the gamma function? E to the power, I am giving one example, px square by twice m beta, okay, dpx. How will you do? Okay, px square beta by twice m you take is equal to x. Okay, then replace. If you replace, then it will be what happen? Px square equal to twice m beta x. So p 2 cancel, px dpx equal to how much? M beta dx. Okay. Now dpx equal to m by beta dx. Px equal to how much? Twice m x by beta. Okay. Now you replace this one, you will get a gamma function, and there is a standard formula in the last class I have given you how to solve it, the gamma function. And if you don't know, after this problem I will go to the harmonic oscillator problem. I will do again the gamma function problem. You can easily understand. Okay. Only to save time. This is how in this case you can do. Or suppose if you confuse, then you want to do this formula partition function. You can use this formula. Integral e to the power minus beta e, okay, and z G D. Now you have to, this equation is a two-dimensional, so you have to replace density function of two dimensional. How can you replace? I have given you formula. This is general formula. You always remember Lx, Ly, Lz. Okay. H to the twice pi to the power d integral d to the power d. Okay, this is a d. This is a number of microstep. Okay, number of microstep for d-dimensional space. K is wave vector. Okay, if I replace k in terms of momentum, then what I will get? Now it is two-dimensional. In two-dimensional case, only term you have to consider. I consider Lx, Ly. Okay, this will twice 2 pi square by 2 square. Okay, if I replace in terms of momentum, 1 by a square integral d square t. D square piece means it is a two-dimensional case. So what I will do? This is area. This will cancel. A square integral d square means dpx integral dpy. Is it okay? So it will be a by a square into p square. P square means what? So in classical particle, I can replace twice me. Is it okay? P square means twice me. So GD equal to how much? GD equal to d sigma de. Okay, equal to a by a square equal to twice m constant. Is it okay? Now I have to replace e to the power a. This is of the 0 to infinity. 0 to infinity e to the power minus beta e. This will give a by a square twice m d. Is it okay? This is a constant. It will come out a square e to the power minus beta e d. Is it okay? Twice m is there. So it is a simple integration. It is 0 to infinity a by a square twice m e to the power minus beta e beta 0 to infinity. Put this limit. Okay, finally you will get a square twice m kt. Is it okay? This is a very easy problem. You can do if you remember directly, or if you can do partition function of that formula, phase space volume, or you can do the same problem using the density of state function. Whichever you like, you do. Okay, I will give all possible paths to solve it. Sometimes what happens, this equation is more easier than calculating from density of state. Okay, then always try to use this function. This is very important because you will encounter density of function everywhere. Then if you remember, if you do this frequently, using density of function, you can remember that this general formula. This general formula is very, very essential. In the last class, I have also given it. Okay, this is the partition function for single particle. For n particle, it will be n distinguishable particle. See, and for n particle, it will be 1 by n factorial. This will be a square twice m kt. Okay, to the power n. Okay, this is the partition function n particle. Now, because in the question they have given this is a by a square twice m e by n. Okay, this is already given in the question because they have given equal to e equal to n kt, mean energy of the system. Then you replace the mean energy. This is the partition function. Once and in exam what happen? Either they will ask the partition function, or what they will do, they will give the partition function. Then you have to find out either entropy or free energy or and pacific heat, something like that. Okay. And if you have any doubt, or if you have any confusion in calculating this parameter using gamma function, because this calculation is not given any books. Okay, books means I am asking you to follow Pathria, R.K. Pathria book. This is chapter number 5. Okay, so in that book this calculation is not given. They have given the expression. Finally they will write the answer. Okay, that is why I am giving the calculation so that you can understand from where they have derived this formula. Okay, and I am going to the next, the application of whatever we have learned: partition function using density function, partition function using phase space volume, partition function, and using general formula. There is a T possibility. Now I am going to apply this partition function in real world problem. Means suppose harmonic oscillator. Why harmonic oscillator is very essential? Understanding of harmonic oscillator is very essential. First of all, before going to give you the detail, what do you mean by harmonic oscillator? That never consider the harmonic oscillator is a particle. Okay, harmonic oscillator is a system which will experience a force against the displacement of the system. This is Hooke's law. Okay. This, what is a harmonic oscillator? Suppose classical harmonic. Classical harmonic oscillator is a system which experience a force followed by Hooke's law. Okay, and this harmonic oscillator is provide a mathematical model. This harmonic oscillator is not a particle. It provides a mathematical model. We mostly encounter many branches of physics. For example, spectroscopy, vibrational phenomena. For example, particle physics. For example, quantum mechanics. For example, condensed matter physics, divine instant theory. Okay, this again I am telling harmonic oscillator is a system that experiences a force followed by Hooke's law F equal to kx, and this model, this system provide a mathematical model to analyze various physical phenomena. For example, vibrational phenomena in spectroscopy, then the phonon phenomenon in condensed matter physics, Einstein divine theory, and quantum mechanics. Okay, there is a lots of examples. So that is why understanding of harmonic oscillator is very essential. Now question number 1. Now I have to apply partition function for harmonic oscillator. Now you have, suppose you clear your concept first. Suppose this is a crystal. This is a d-dimensional crystal. D-dimensional crystal means suppose I consider 2 3-dimensional crystal. There is n atoms. You clear the concept. This is a, I am telling you, this is a crystal. Suppose this is a d-dimensional crystal. D-dimension, suppose I consider 3-dimensional crystal. Okay. Then number of atom is how much? Number of atom is n. So a single atom, remember, a single atom is equivalent to 3 harmonic oscillator. Remember, a single atom is not equal. I am not telling it is equal. I am telling that single atom in a crystal, suppose 3-dimensional crystal, is equivalent to 3 independent harmonic oscillator. Okay, 3 independent harmonic oscillator means Hamiltonian. You can write like this: px square twice m plus v1. V1 means half kx square. Okay, I am writing half k x square. Okay, next py square by twice m plus half ky square. Okay, next twice py z square by twice m plus half kz square. Okay, clear? That means is any crystal, suppose a crystal, there is an atom. I am telling you again, and a single atom is equivalent to 3 harmonic oscillator, 1, 2, 3. It's simply we write like this. Always never confuse. Simply we write half k r square. Do not confuse. This is not to 1-dimensional. This r square means x, y, z. P means px, py, pz. There is a theta. Okay. So a single atom is a 3 independent harmonic oscillator, and n atom. Suppose if there is a n atom, so there will be Thyssen independent harmonic oscillator. See, 1-dimensional harmonic oscillator. Whenever you study the Pacific heat theory, Einstein or Debye model, whatever it is, you will find there is a Thyssen harmonic oscillator. So why? Because single atom has a 3 harmonic oscillator. Why? N atom means there is a Thyssen numbers of harmonic oscillator. Remember, do not confuse. Okay, clear? In equipartition theory, again I am telling that Equipartition theory, this suppose in exam, what type of question I will ask, what type of question exam asks, I will tell you detail. This is a one dimension. How many harmonic term is there? 1 term, 2 term, 3, 4, 5, 6. Okay, only harmonic term. So degree of freedom 1, 2, 3, 4, 5, 6. 6 degree of freedom equal to how much energy? Energy, one harmonic oscillator mean energy how much? 6 into half kg, right? 6 into 1 atoms mean energy 3 kT. 3 kT, right? So if there is an atom, then mean energy will be how much? Thrice n kT, right? This is according to equipartition theory. Okay, then Pacific, this is the mean energy. Okay, Pacific is equal to du by dt equal to how much? Thrice nr, thrice n k equal to 3r. Is it right? 3r means how much? 5.96 calorie Kelvin inverse. This value you have often get in the books. Okay, this is mean energy of a three-dimensional crystal having n atoms, and this is a classical calculation. This is the equipartition theory is totally classical, and this value is thrice r is a Dulong and Petit law. Okay, you have about Dulong passivity, classical passivity is Dulong and Petit law, and quantum mechanical passivity theory is provided by Einstein and Debye. Okay, I will discuss in details, but before that I want to give you idea. So what now I am telling you, there is a three type of oscillator. One is a classical oscillator followed by f equal to kx, right? One is a classical oscillator. Energy is given by this one, where equipartition theory is whole. This is a classical oscillator. Clear? One is Schrödinger oscillator. Okay, quantum mechanical oscillator. Schrödinger oscillator, energy of Schrödinger equal to oscillator is how much? N plus half h cos omega. This is Schrödinger oscillator. Remember, do not confuse. And one oscillator is energy is equal to n h cos. No 0 point energy. This oscillator is known as the Planck oscillator. We have calculated in black body radiation, right? So during that we have used this energy, this formula. This is a Planck oscillator, this is Schrödinger oscillator. This what we are calculating here using equipartition theory, that is a classical oscillator. Okay, clear? Now, this suppose one equal to n h cos omega. This is a Planck oscillator. Remember, Planck oscillator. Okay. This n equal to n plus half h cos omega. This energy we are getting from where? Suppose in vibrational energy spectra, energy of harmonic oscillator. From where we are getting it? So by solving Schrödinger equation. Okay. This is why this is called Schrödinger oscillator. Schrödinger oscillator. Okay. Oscillator. And third one is kT. This is average energy of classical oscillator. Remember, for a single particle, this is classical oscillator. Clear? And this is used in passivity theory, Debye and Einstein. Okay, clear? And now I am telling you one basic concept not related to this. That what is the basic difference in Debye theory? So Debye theory is going to calculate the passivity. Now in a passivity of a solid is contributed by electron and phonon. Clear? Passivity of a solid is contributed by one is electron, second is phonon. So Debye and Einstein theory going to calculate the passivity of solid due to phonon interaction or phonon contribution. Okay. This is the theory of Debye Einstein. Here it is Debye and Einstein. Okay. Now what is the basic difference of Debye and Einstein? So both are using this Planck oscillator. If you see the book, they will use the Planck oscillator. E equal to n h cos omega. But what is the basic difference Debye and Einstein? That in Debye, according to Einstein, if a crystal consists of n numbers of atoms, there will be thrice n number of independent harmonic oscillator. Independent. Okay. I have already told you, if n atom, there will be 3 harmonic oscillator. And if a single atom, there will be correspond to 3 harmonic oscillator. If there is an n atom, there will be thrice n number of harmonic oscillator. Here, in Einstein told that that if there is an atom, there will be Thyssen number of independent harmonic oscillator. Each harmonic oscillator vibrate with a common frequency. That's why omega is fixed for all oscillator. Okay, but in Debye theory, Debye told that although there is a Thyssen number of harmonic oscillator in a crystal of 3 dimension, okay, but this in the vibration of harmonic oscillator is not independent. They will have a different frequency. That is why they will put a limit 0 to minus 3. What are the frequency they are good? That's why they do the integration 0 to infinity. They don't know. They told that frequency is a continuum and it is take any value 0 to infinity. So that is the basic difference Debye and Einstein. I am going to calculate why I am more giving more focus on statistical, because if you see Debye Einstein theory, you no need to study in condensed matter physics. And if you the application, next application, paramagnetism, ferromagnetism, then no need to study condensed matter physics, same topic. Okay. Now, okay, this is the basic. Now I am going to calculate the partition function of a harmonic oscillator. Okay, clear? Now it is clear. This is n numbers of, suppose n numbers of one-dimensional harmonic oscillator. Remember, 1D harmonic oscillator, one-dimensional. So I am going to calculate the partition function. This is what classical system, where equipartition theory can be applied. Okay, so I will write Hamiltonian of the system p square by twice n plus what? Plus half kx square. Is it okay? This is a one-dimensional system. X, if you confuse, then you can write px square by twice n plus half kx square. Okay, or you can replace it. You can express as a px square by twice n plus half k. You can replace k means what? K means omega square m q dot square. You can replace q dot square, because this is in statistical. We are often talking about momentum space. Not q dot, sorry, q square. This is momentum space means what? Statistical space means momentum and position coordinate. Generalized coordinate, q, you can write like this. Okay. So I will write general formula 1 by h d integral e to the power minus bh. Bh means this is okay. You can replace some in some book. You can replace E also. E means total energy. This is a Hamiltonian operator. If you take the perturbation theory, if you see the perturbation theory, what I have already given in quantum mechanics is phi. This is the Schrodinger equation. E and phi. E and phi. This is the eigenvalue equation, right? Okay. Phi. Then if you take the phi in both sides, phi is phi equal to En is constant. You cannot take the expectation value. En will come out phi. So En equal to phi is phi. That means energy is the average value. Energy is the eigenvalue of Hamiltonian operator. So in some, that is why you can replace B equal to H, you can replace with the energy eigenvalue. Energy eigenvalue of Hamiltonian operator. Or you can replace this term also, no problem. dd omega, right? dd omega, clear? You do not confuse again. Okay. dd omega means d-dimensional momentum space. So this is a one-dimensional case. So one-dimensional case, I will write 1 by h. Clear? One-dimensional case. So I will write e to the power minus bh. I will replace this term. I will replace here. So it will be dq dp, right? This is one-dimensional momentum space, right? dq and dp. So I will, because of space limitation, I am putting again here. So this z equal to 1 by h. Clear? Is integral e to the power minus, you see, say carefully, beta p square by twice n. I am not writing px, okay? This is dA dp, right? Is it okay? Next term, integral, this is always 0 to infinity, okay? 0 to infinity. Next term will be, if I replace beta half a square, e to the power minus twice beta kx square, or you can apply q square also, because I am writing here q, you can apply q square and dq. Is it okay? This is the expression. Oh, sorry, m is omega k half k square, or t. Okay. 1 by h e to the power minus beta p square by twice m. Okay, no need. Now you use the gamma function. How you see carefully how I will use the gamma function. This is a two different integral. Okay, you can take it 1 by h I1 into I2. This is a two different integral. So first I will define I1. So I1 I have to consider this term. You always consider the x. So beta p square by twice m equal to x you consider. Okay. Next 2p dp, because I am going to, because this is a dp, I am going to transform gamma function. Why I am telling you right now is just exponential, whole exponential term you consider the x equal to twice m x, twice m dx, right? 2 to cancel. So dp equal to how much? M dx. P means what? P means x by twice m by beta x, right? Into I have committed mistake. I am writing a p square. I am writing again so that there will be no confusion. Beta x. Is it okay? So I will take the differentiation both sides. So this will dp, right? Next time it will be twice m beta dx, right? So 2 to cancel. 2 to I remove 2 2. So dt equal to m by beta equal to dx by p, right? P means what? M by beta dx. P means P means twice m beta x, right? Beta beta cancel. I can replace m by 2m beta, right? X to the power minus half dx. This value I will put it here. 1 by h integral e to the power minus x. I am taking e to the power minus x. Okay. And dp equal to this one, m by 2m beta x minus half dx, right? And similarly next integral, this is for first term, and now it do this, do for this, and this is minus, sorry. Now for this term, second for integral beta k, or you can replace beta m omega square. K means m omega square, but that's why I replace. So q square equal to, or you can, if you confuse, you can replace x also, no problem. So by 2 equal to, you consider equal to y, or you can see, this is q, you write down q. So same way you have to, and q square equal to how much? Twice y by m omega square beta, right? Q square equal to. So it will be 2q dq equal to, this is 2 dy m omega square beta. Okay. 2 to cancel. You will get dq equal to how much? dy m omega square beta into q. Q means what? This is what? Twice y m omega square beta. Okay. Twice y omega cancel. It will be how much? dy twice y m omega square beta. Okay. dy means it is dy twice m omega square beta y inverse half. Is it okay? Now I will put e to the power minus ui dy 2m omega square beta y half. Okay. This I will get this integral. So I will take the constant term, I will take out is 1 m by twice m beta, this is under root, okay. This integral 0 to infinity e to the power minus x minus half dx. Similarly, this I will take out, I will remove this part also. In this part I will take it out, 1 by 2m omega square beta, okay, 0 to infinity, first integral e to the power minus x minus half dx, next integral 0 to infinity e to the power minus y minus half dy. Is it okay? This term is gamma function. Okay. So what is a gamma function? What is a gamma function? So you see, gamma n plus 1 equal to, now you can consider here integral is lower limit is 0, upper limit is infinity. If you take the limit, upper limit, lower limit will not change if you take it. See how, that's what I am going to give you. First term beta p square by twice m equal to, I consider x. You see this is lower limit for p and upper limit for p. Okay. When p equal to 0, x is also 0. Okay. When p is equal to infinity, x equal to infinity. That's why I am not changing the limit. Okay, clear? Similarly for here. Now back to the beta function, gamma function. E to the power minus x to the power n dx. n plus dx. This is one formula. This formula in the exam, net exam, they will give this formula. Okay, don't worry. This formula they will give inside the question. And next one, gamma n plus 1 equal to n factorial. Okay, and gamma half equal to root pi by 2. This formula you remember. So this is what, e to the power x, and in place of n equal to half. So it will be half minus half plus 1 equal to, we are getting, you will get gamma half equal to root pi by 2. Is it okay? So it will give root pi by 2, it will give root pi by 2. Finally you will get 1 by beta h cos omega. Clear? You will do calculation. I am giving the stepwise calculation. Okay, once you know how to use gamma function, once you find this value, you can easily put this value using that gamma function. No need to give transformation. I have given this transformation only to understand how to calculate this partition function using gamma function. Okay. So what I will get? A system of, again I am back to the question, a system of n harmonic oscillator, n one-dimensional harmonic oscillator. Clear? So partition function for single harmonic oscillator, one-dimensional beta is cos omega, or you can represent kt by is cos omega. Remember, this is the partition function of a single one-dimensional harmonic oscillator. Okay. Now my question: for n-dimensional harmonic oscillator, suppose this system composed of n particles. So what will be the total harmonic oscillator? It is kt by h cos omega to the power n. It will be like this. Okay. This is the total partition function of the system where there are n one-dimensional harmonic oscillator. Clear? Suppose if this harmonic oscillator is a distinguishable, totally classical system, then there will not be n factorial. Okay, clear? Suppose, now question is that, suppose if I give you, suppose if I question it, I have seen the question in the net paper. If the harmonic oscillator of if a system, question is like that, net question. Okay, you listen the question carefully. A system composed of two particles. A system composed of two particles is where Hamiltonian of the system is given by like this. Okay, for single particle, px square by twice m plus half kx square plus py square by twice m plus half ay square. Clear? I am telling again, a system composed of two particles, Hamiltonian of a single particle is given by this one. What will be the partition function of the system? So how many one-dimensional? This is one-dimensional harmonic oscillator. This is one-dimensional 1D harmonic oscillator. This is 1D harmonic oscillator. So what will be the partition function for single particle? How can you calculate? Now, whether this partition function, this is partition function 1, this is partition function 2, suppose. So total partition function will be whether this one or this one. Which one is correct? Now you have to tell me. Whether total partition function is a product of two individual harmonic oscillator or sum of harmonic oscillator. Which one is correct? But this one is correct, this one is wrong. Okay, why I am telling you? Because whenever I calculate the partition function, suppose this is h to the power e hd, e to the power minus beta is, beta you have to put it here. Okay, there will be one, this will give two integral. This will, one integral I have given you. This will give two dimensional, I have to write dpx, dx, dpy, dy. Okay, this is what? Two dimensional calculation. So this term will be given by this one. I will write, this is a two dimensional case, e to the power minus beta is. So first integral will be dpx dx. Next integral e to the power minus beta is y. This is y term, this is x term. X term means this is hx, this term, this hy. Second component. Okay. So it will be dpy dpz. Okay, this is for, this is z1. Okay, this is for z1. Z1, this is z2. Okay, so total partition function z1 into z2. Okay, always product, never sum. Do not confuse. Now I have already derived the partition function single harmonic oscillator. Correct? So what will be the partition function of this system? So what I am getting here, suppose if partition function of single harmonic oscillator, I am getting kT by beta omega. Okay, so this is partition for a single harmonic oscillator. Single harmonic oscillator for partition function I am getting here kT omega h cos omega, and this I am getting same formula omega h cos. Correct? So total partition function will be this one kT h cos omega into kT h cos omega. Okay, and another important thing you have to focus. Okay, another important thing that if both one-dimensional harmonic oscillator, this harmonic oscillator and this harmonic oscillator is, if it is independent means not, it is independent, it is different, it is not related to this one. So if they vibrate independently, if it is not isotopic system probably you have understood. Isotopic system means all harmonic oscillator have the common frequency. Okay, isotopic means having same property along all direction. Having same property means omega along x direction, this is x direction, is same as omega along y direction. Then it will be, you can write as a square kT by h cos omega square. Otherwise, if it is anisotopic substance, anisotopic medium, that means the harmonic oscillator along x direction is not similar to the along y direction. Then what happens? Partition function will be kT omega h cos omega x into kT omega y h cos. Okay, clear? Okay, this is a, again I am telling, this is a partition function for single particle, not for all particles. It is single particle harmonic oscillator, Hamiltonian of a single particle is given by this one. Now system composed of two particles. So what will be the partition function? So normally what I am doing is like that. Now total partition function kT h cos omega to the power n. N means n number of particles. Now I have considered system. Suppose this is a system, there is a two particle, one particle, there is a two particle. And Hamiltonian, this is a Hamiltonian of single particle. Correct? So this is partition function, I am getting partition function this one. This is partition function this one. This means partition function of a single particle. So total partition function will be what? Kt by omega is cos square into square. Okay. So that means it will be partition function. Partition function will be Kt is cos omega to the power 4. Do not confuse. Clear? Okay. Now suppose a system. Now I am going to the crystal. Okay. Crystal means suppose this is a crystal. There is a n numbers of atom. N numbers of atom. N number of atom. This is a n number of atom. Okay. And harmonic oscillator. You see harmonic oscillator. Hamiltonian of this is normally written as like this: p square by twice m plus half k r square. Okay, normally written. Don't confuse. This is a one-dimensional harmonic oscillator because r square is there. That means it will x y z t component. So p square px square by twice m plus half k x square plus py square by twice m plus half k y square plus pz by twice m half k z square. Okay, this is how many harmonic oscillator is there? One harmonic oscillator, one harmonic oscillator, one D harmonic oscillator, one D harmonic oscillator, one D harmonic oscillator. Clear? In net get question, they will mention the energy of a single harmonic. They will give a question like that: a single harmonic oscillator, a partition function of a harmonic oscillator is given by this one. Then what is the partition function of a crystal of three-dimensional? Okay, and where there is n numbers of distinguishable particles. Then what is the partition function? They will give the partition function of a single atom. This is how many harmonic oscillator there? 3 harmonic oscillator. Partition function of will be Z1 into Z2 into Z3, right? Z1 means this is for Z1, this is Z2, this is Z3, right? So it will be Kt is cos omega cube, right? To the power t. Okay. It is only isotopic case. Isotopic means all harmonic oscillator vibrate at a common frequency. Isotopic means normally what do we mean by isotopic substance? A substance having any property. Suppose it may be electrical property, it may be magnetic property, whatever it is. Along x direction property, along x direction, and along y direction, along z direction. Yeah. This property is supposed. If I want to measure the conductivity, this is a crystal. The conductivity along y-axis, along z-axis, along x-axis. If it is similar, then it is called isotopic substance. Suppose conductivity along x-axis is not similar to the along y-axis, along z-axis, all are three different, then it is called anisotropic substance. In isotopic substance, isotopic behavior harmonic oscillator, that means omega is common, that's why I am writing cube. Okay, you consider this is isotopic substance. Then, if the system composed of n numbers of atoms, then how many? What will be the partition function? Kt is cos omega to the power n t. Okay, to the power n. Okay, that means what is the partition function for? This is a classical partition function. Don't confuse. This is a classical partition function of a system of n particle or n atoms. This is I can represent Kt by is cos omega Tyson, right? Clear? So the general formula I can derive. So general formula, general partition function. Now you see the partition function general formula. This general formula you never find in the books. I have derived after this all calculation. Okay. General partition function. Remember Z equal to Kt is cos to the power dn. It is not derivative. Dn is not derivative like that. Dn. This is not derivative. D stands for dimension, n stands for number of particles. Okay. Suppose if I talk about crystal of two-dimensional crystal. So you see, you may confuse. If I ask you a system of two-dimensional system, this is a 2D system, D equal to 2. Okay. Then n numbers of atom is there. N numbers of atom is there. So what is the partition function? If partition function of a single atom is Kt by is A square omega. Then what will be happen? You will remember this formula. Z equal to KT A square omega 2n. This is the answer. This is how you have to remember. So another, I am telling you another question. Clear? Okay, question is another question. If you solve it, this question comes in the NET exam. This question comes in the NET exam. This question comes. Question you read very carefully. Question reading of question and understanding of question is very, very important. Once you understand the question, you can easily find out the correct answer. Many hints are given already in the question itself. Okay. So this question comes in the exam. Consider system of two atoms in equilibrium, thermal equilibrium temperature T. Okay. This is a considered system of two particles at temperature T. Clear? Then Hamiltonian of the system, Hamiltonian of a particle is given by, Hamiltonian is given by like this, P1 square by twice m. So P2 square by twice m, half K R1 square plus half K R2 square. So now you may confuse. This is P1 square by twice m plus half K R1 square plus P2 square twice m half K R2 square. Why I am giving you now? You can see now you may confuse. This can one the harmonic oscillator. You may confuse. Okay, this is one dimension. This is wrong because the system is composed of two particles. That is why this is a partition. This is a Hamiltonian of a. This is a Hamiltonian of a one particle. One particle means there will be how much? You can express P1 x square twice m, P1 y square twice m plus Pz 1z square twice m plus this is half K x1 y square plus z square. Okay. Similarly, this you can express. That means what? How many degree of freedom? There will be 1, 2, 3, 4, 5, 6. This part there will be 6 degree of freedom. There will be 6 degree of freedom, and this is equivalent to what? This is equivalent to 3 independent harmonic oscillator. Okay. This is equivalent to 3 independent harmonic oscillator. This is one harmonic oscillator Z1 into Z2, Z3. This first term will give Z1, Z2, Z3. Second term, similarly, second term will say how many independent harmonic oscillator? There will be 3 independent harmonic oscillator. It is for one system. 2 is for two particles, second particle. Okay. So Z4, Z5, Z6, 6 partition function will be there, and one partition. Now the total partition function will be how much? Now partition function equal to how many harmonic oscillator? One dimension harmonic oscillator. This in this Hamiltonian, one particle 3 harmonic oscillator, and the next particle 3 harmonic oscillator. How? One harmonic oscillator Z1 to Z6, right? One harmonic oscillator partition function KT by A cos omega into KT A cos square omega equal to KT A cos square omega 6. Do not confuse. Okay. This is the total correct form. Otherwise, if you write it is equivalent to 2 independent harmonic oscillator, because you have seen there's a P1 square by twice m plus half K. Now one important thing, once there is a Kr, it is not XYZ, then you always remember these are contain XYZ. Okay. Do not confuse, do not think that it is one dimensional. So that will be the correct answer. So I am not going to, because of time, many things is there. So in exam, why I am telling you detail, because what happened in the books, they are calculating partition function for single one-dimensional harmonic oscillator. But in the exam, what happened? They will give partition function of two-dimensional particle. Always confusion. So students get often confused. So that's why I am telling you the detail. If it is like that, then it will be this. If it is like that, then it will be this. Okay. Now in exam what happen, they will not give you all the question. Either they will give partition function, you have to find out entropy, or they will give you entropy, you have to find out mean energy, something like that. So suppose partition function is given. So what is a partition function? Avoidal partition function, we are getting this one, kt is cos omega to the power n. This is for indistinguishable, distinguishable classical particle. That's why I am not writing 1 by factorial n. If it is suppose question is like that, that is why you read the question very, very carefully. If the particle are indistinguishable, then you write 1 by n factorial. Okay, I am doing this calculation for this distinguishable particle. What is the free energy? Now I am going to calculate free energy. Free energy. Okay. Do not no need to remember this formula. Everything they will given in a question paper. They will give the partition function of a single harmonic oscillator. A harmonic oscillator, a system of harmonic oscillator, and harmonic oscillator is given by this one. What is the free energy? A equal to, we know this free formula, kt ln z, right? So kt ln z means ln kt is cos omega to the power n, right? So it will be kt n kt ln is cos omega by kt, right? So now one thing you have to be very clear. So kt is the mean energy of classical oscillator. Mean energy of classical oscillator. How you can calculate the mean energy of classical oscillator? What is the value of calculation in quantum mechanics? It is like that. Okay, I am telling you, quantum mechanics it is like that. It is in quantum mechanics. In continuous system and in statistics it is like that. Statistics is a minus beta ER non-degenerate system. Okay, ER is a minus beta ER in statistics. It is in continuous Dirac notation. It is in this is also for discrete system. This is also for discrete system. But in case of continuous system, if I measure the mean energy, so how I will do 0 to infinity. What will be the dS? Sorry, not dS. d cube omega. D cube omega means you have to write the whole formula. Okay. Here you have to write E dS d cube omega. If you calculate, you will get the energy equal to kT. So that means classically energy of classical oscillator is kT for single oscillator. So in question they will give that if E is equal to nkt. Nkt means this is the energy of classical system. N stand for n number of particles. That is why this is the mean energy for n particle in classical system. Then you have to replace nkt ln is cos omega by E by n. Sorry, E by n and E. Okay. So why I am giving this? I have seen a question paper. So they will given the if the partition function, if the question is like that, if the partition function of a harmonic oscillator, one dimensional 1D harmonic oscillator, z equal to kt is cos omega, then which of the following is the correct answer of free energy? Then you may get this answer, but it will not match with any answer. So that's why you have to transform like this. Now another question is that this is cos omega. H cos omega is what? En equal to what? N plus, this is a Schrodinger oscillator, okay? This is oscillator. This is, so I am talking about Schrodinger oscillator, okay? This is R equal to R naught, equilibrium function. So En. So En minus plus 1 minus En, if you take the differentiation 1, that means this equal to H cos omega, band gap. Band gap in harmonic oscillator is a fixed constant in harmonic oscillator. And harmonic oscillator, this is a different. So it is the band gap. So sometimes they will express it is like that. nkt ln band gap E equal to n E. They will write like this also. Do not confuse. And sometimes they will get the nkt equal to how much? Nkt equal to E ln del E n by E. They will express it like this also, like this also, like this also, like this also. Okay, they will ask the question, if the harmonic partition function of a single one-dimensional harmonic is like that, which of the following is the correct free energy, correct form of free energy? You do calculation, but you are getting here, but you after that you are not getting any correct answer, which is matched with the answer given in the question paper. So sometimes you have to convert like this and convert like this, convert like this. Okay. Okay. So thank you. In the next class, I will continue to the next class in the next class. I will continue this part, because this is I am talking about classical harmonic oscillator. Now I will 1D, 2D, 3D calculation, that is not necessary. Okay. In the last one, I want to give you another formula. So partition function. See, again I am telling partition function 1. This is for 1D harmonic oscillator, KT is cos omega, right? 2D harmonic oscillator, Z equal to KT is cos omega square. 3D harmonic oscillator. 3D harmonic oscillator means what? One atom. Remember, harmonic oscillator Z equal to KT is cos square T. It is 2. Okay. Now it is for 2D, and it is, remember, it is for isotropic harmonic oscillator. Isotropic harmonic oscillator means all one-dimensional harmonic oscillator have common frequency. Okay. I am writing again. This is KT is cos omega x. Then it will be 2-dimensional. What will be there? KT is cos omega x into KT is cos omega y. Correct? Because why I am writing here? Because this is an anisotropic substance. Anisotropic harmonic oscillator means frequency omega is not equal to omega y. That's why I am not writing square. Okay? And it will be T, KT is cos omega x into KT is cos omega y into KT is cos omega z. Okay, clear? This is for isotropic, omega x, omega equal to omega z. That it will then you can write Q. And this is anisotropic. Anisotropic means all in one-dimensional harmonic oscillator have different frequency of vibration. Omega, that means omega x not equal to omega y, not equal to omega z. Then you have to write partition function like that. Clear? Okay. And last one is the general formula. General formula, better you remember the general formula I am giving it. KT, this is only for classical system. A is cos omega dn. D stand for dimension, n stand for number of particles. Okay. Suppose, how can you identify whether which dimension in question they may not mention which dimension. Suppose I am writing Hamiltonian. Hamiltonian phase of P1 square by twice. Okay. Half KR square, P2 square by twice and half KR2 square. Now they have not given anything. How can you identify this which dimension, how many particles? So when P1 KR1 square, this is for one particle, okay, and this is for one particle, okay, one particle. Now it is KR square. Now the question is mentioned in that somewhere they will give a hint whether it is 1D, 2D, 3D. Even though this is for 3D, this is for 3D. Okay. Then 3-dimensional T, it will be T. So total dimension will be number of particle 2. It will be 3 dimension. So total will be how much? KT is cos omega 3 dimension 3 into 2 particles. So it will be KT is cos omega 6. Okay. Clear? This is how you have to remember. This is easy way to remember. That's why I am giving the general formula every time. So once you do the calculation, after that you remember the general formula. Using general formula, you can easily guess. I hope I hope you can after this completing this class of chapter number 3 of Pathria book, most of the question comes in the NetGet exam. You can easily do, and you can check it whether you can do. I do believe that you can do it. No problem. Thank you.